All right, section 6.2, we continue on with random variables. In this section, we're going to be combining random variables. We're going to look at the effects of transforming, so adding and subtracting, multiplying and dividing by a constant, which we've done earlier in the course, and then finding probabilities based on that. So let's take a look at what we got here. Okay, linear transformations we've done before. Remember, adding and subtracting affects measures of center and location, but not shape or spread. For spread or variability, you're just shifting the distribution. It's not changing the distance between values. But multiplying or dividing affects everything, center, location, and spread, but not shape. Not shape. All right, so we have this distribution, the number of passengers for Pete's Jeep tour. There's a histogram. It's unimodal, roughly symmetric. And now we're looking at the total amount of money he collected. So he collected $150 per passenger. So what you'll notice, it's just the number of passengers times 150. So the distribution looks exactly the same. It just has been shifted. So the center is different, but nothing else is. So the mean was 3.75 passengers times 150 now. The mean for the cost is $562. The standard deviation, 163, is still the same thing. Actually, it's not exactly the same because you're multiplying by 150, sorry. So it's the 1.08 times 150, which is $163. It's not just a shift, it's a rescale. The shape is the same, and everything else changed. Measure of center, measure of location, measure of variability, because you're multiplying by that. So multiplying by a constant, when we talk about variance, which is something that we're going to talk about a little bit more, variance is the standard deviation squared. So when you multiply by a constant, it's the constant squared. That's how it affects the variance. So that's going to come into play in this unit for sure. All right, adding and subtracting. So it costs him $100 to buy a permit, gas, and stuff. So those are his costs. So if we take the previous distribution and just subtract $100, now I'm subtracting. I can see the shape is exactly the same. The mean, which was, I think, 562.50 minus 100. The standard deviation is exactly the same, however, because we're just shifting the data. We're not doing a rescale. And this is just a review of things that we've done in the past. So, if we take a look at this question, let's check your understanding. I would pause this now and work through it. Okay, so they give you the mean and standard deviation. They get a $500 bonus. So it's going to be 500 times the number of cars sold. So the new mean, this is a rescale, 500 times 1.1 is going to be $550. And the new standard deviation, whatever 500 times 0.943 is, that's going to be the standard deviation. Again, because it's a rescale, it affects measures of center and variation. For number 2, they're going to provide coffee and donuts that cost the manager $75. So the profit is going to be 500 times the number of cars sold minus the 75. So essentially it's going to be these same two answers, except I'm subtracting 75. That affects measures of center, so the new mean is going to be $475. But the standard deviation is not going to change because doing a shift does not affect the variation. So you can see that here. So they just summarize when you're doing they're called a linear transformation. Linear transformation is just going to involve adding and subtracting or multiplying and dividing. So the rules for a random variable are the same that we've learned earlier in the course. So that's nice to know. What do we got here? Okay. So this is a conversion from Fahrenheit to Celsius or vice versa. We've done this before. There's not going to be anything new there. Except now they're talking about a normal distribution because they're talking about the temperature of the water. So this is a continuous random variable. And they're just using a normal distribution. Same thing that we've done in the past to find the mean and standard deviation. first they had to find the mean and standard deviation in terms of Fahrenheit, so doing conversions. Now for the standard deviation, you don't need to add the 32, so you'll notice for their calculation they just did 9/5 times 2 to get the new standard deviation in terms of Fahrenheit. And then just calculating z-scores and using normal CDF to find the area under that density curve. All right, let's move on. So now the next section gets into this idea of combining random variables. So now, instead of having one random variable, what if you have two independent random variables? So we have Pete's Jeep tour again. We have number of passengers. And now Erin, his sister, is going to join the tours, and she's going to do her own bookings. So she has her own distribution for number of passengers. So now it's saying how many total passengers will they have. So I'm just going to be summing up the number of passengers for Pete and Erin's Jeep tour. I don't want to get into the probability too much right now. So we have to assume or be told that these are independent random variables. And to define that, knowing whether any event involving X by itself has occurred tells us nothing about any event from Y occurring, and vice versa. So similar to independent events. Okay, so here is the combined distribution for the total. They did some work to find the new probabilities. So now when I find the mean of the total, it's going to be 6.85. And what's interesting is if you notice here, 3.75, the mean for, what's his name, Pete, plus Erin's mean, 3.1. If I add those two up, I do get the 6.85. And then for the new standard deviation, it's 1.44. But you'll notice, if you just simply add the standard deviations, you do not get 1.44. Standard deviations do not add. What does add? Their variances add. This is extremely important. And you'll see the formula right here for the variances adding. The variance of the total is equal to the variance of X plus the variance of Y. How do I know it's variance? Because it's the standard deviation squared. All right. So if I have multiple random variables, 3 or 4 or 5, and I need the standard deviation, I'm going to sum up their variances and then take the square root. Just worth saying again, we're never adding standard deviations. Not doing that. So here's an example. We have SAT portions, math and critical reading, and they want the total score. The mean, I'm just going to add those up. The variance, here I can't just add the variances to find the standard deviation because these two random variables are not independent. Because typically students who score high on one part of the SAT tend to score high on the other part. So we have to check, are the random variables independent or not? And if they're not, we can't do anything to find the standard deviation. Okay, so excuse my yawn, my goodness. So here we're taking a look at rules for adding random variables. This just gets into cost now. It's combining what was in the previous section that we talked about doing linear transformations with multiple random variables. So they're finding their cost combined to get the average combined cost. And then you'll notice the means play nice. Basically, you take the means times the cost, add them up. Standard deviations do not. The variances add because they're independent random variables. And what I'm going to need to do here, though, is find the rescaled standard deviation. So the 150 per ticket times 175. I have those values. That's the standard deviation of the rescale. And then I'm going to square those because I'm going to be adding the variances. So there's a lot that goes into that. We'll dive further into that as we go on. Okay. This idea, and we'll talk about this in class too, that x1 and x2 are not the same as 2x, especially like this. And the example I'd like to give is this. Say we have a random variable x, and that's how long it takes you to get ready in the morning from when you get out of bed to when you're leaving to come to school. So that's going to be a random variable. It's going to have a mean. It's going to have a standard deviation. But every single day, Monday, Tuesday, Wednesday, Thursday, Friday, assuming we're in a normal setting and you go to school every day, if I want to start looking at the mean and standard deviation of the time it takes you for the entire week, it's not just 5x. That would mean we have one random variable, and we're just multiplying it or rescaling it by 5. But every single day is its own random variable. So it would be x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5. For the mean, you're just going to add the mean 5 times, which would be the same as doing 5x. However, for the standard deviation, I'm not just doing a rescale of 5 times the old standard deviation. I'm having to add the variance 5 times and then take the square root of that. So these are not the same. This is 2 independent random variables. This is 1 random variable. Okay, so this check your understanding. We want to find and interpret the total mean. So the mean here is 1.1 plus 0.7 means play nice. I'm just going to add those, 1.8. The interpretation is going to talk about like the law of large numbers. Over many, many Fridays, the dealership sells or leases about that many cars in the first hour of business. Compute the standard deviation of the total. So now we're adding the variances. So I'm going to have 0.943 squared plus 0.64 squared, and I'm going to take the square root of that to get the standard deviation. So I'm adding the variances, taking the square root to get the standard deviation. So now in part 3, they're getting a $500 bonus for each car sold and a $300 bonus for each car leased. So it's 500 times x plus 300 times y. Means play nice, so I'm going to do 500 times the 1.1 plus 300 times the 0.7 for the mean, which you can see here. For the standard deviation, a lot different. I'm going to add the variances, but we talked about this earlier. When I'm talking about variance, it's going to be the rescale squared. So it's 500 squared times 0.943 squared, the variance of x, plus 300 squared times 0.64, the variance of y squared. And then I'm going to take the square root of that value to get the new standard deviation. So this is kind of tricky to explain in a video. We're definitely going to cover this in class. It is a big piece of what we're doing. The second part here, difference of random variables. So now if we did subtraction, the order of subtraction is important. So subtraction is not commutative. You can't change the order and get the same thing. So for means, they play nice. If you're subtracting, just subtract the means in the order that they give you. The standard deviations, again, they do not. The variances always add. It doesn't matter if you're adding or subtracting the random variables, the variances always add. So you'll see here we have a difference, but the variances are adding. And an example I want to give you is, say you have a bottle of water that's supposed to have 20 ounces in it. So you have 20 ounces, but there's some variability in there from the manufacturer. Say you pour a glass of 8 ounces of water out of that bottle. Well, when you poured 8 ounces, you didn't pour exactly 8 ounces, so you have a little bit more variation there. So there's 12 ounces left, so you've subtracted, but you've added in more variation. You have the variation from the original 20 ounces plus the variation from the 8 ounces that you poured out. So hopefully that maybe helps you see, even though you're subtracting, you're still adding in variation. Okay, so here you're doing the same thing, but looking at the difference. So the mean difference, they're doing x minus y would be 1.1 minus 0.7, 0.4 So that's your mean difference. Standard deviation is going to be exactly the same. Add up these variances, square them, and take the square root. So that's the same as it was in the previous one. For the mean for this part 3, the mean is going to be different because you're doing 500 times x minus 300 times the expected value of y. But the standard deviation is exactly the same. We're adding. Doesn't matter if we're subtracting, we're always adding variances. Let's see how many sections we got here. Okay, so combining normal random variables. So this gets into this idea of what if we have continuous random variables? So if we have normal distributions, the means, sum, or difference, the distribution is still going to be normally distributed. So I like this question quite a bit here. Okay, so he is following this idea that he wants this many grams of sugar in his cup of tea. He adds 4 randomly selected packets of sugar. So remember, this is not just 4 times x, because each packet of sugar is its own random variable. They follow normal distribution with this mean and the standard deviation. So you have 4 independent random variables. So the mean would be the sum of those 4, packet 1 plus packet 2. So the mean is 8.68 grams of sugar. And the standard deviation, I'm going to add the variances, so the 0.8 squared 4 times, and I'm going to take the square root of that to get the standard deviation, 0.16 grams. So now we have this normal distribution that has a mean of 8.68 grams and a standard deviation of 0.16 grams. And now I'm just using the normal distribution with those 2 parameters, calculating a z-score, and using normal CDF to find the area under the curve. This is just another example talking about the size of the lid on a cup. We're looking at a difference here. So you're going to have to calculate the new mean and standard deviation of the normal distribution of the sum or the difference of 2 independent random variables. And then use those parameters to calculate z-scores, and then use normal CDF to find the area under the curve. So if we look at a summary here, we started with talking about linear transformations, how they affect center, shape, spread. Remember, center is affected by both adding and subtracting and multiplying and dividing. Shape is not affected by any of those. Spread is only affected by the rescaling, multiplying and dividing. We talked about then if you have independent random variables like means, do whatever it says. If you're adding, you're adding. If you're subtracting, you're subtracting. But for the standard deviations, the variances always add, provided you have independent random variables. And then we combine those 2 concepts into what if you have shifting and rescaling with multiple random variables, as you saw in the last example. And then this just gets on to the exercises. So, pretty dense section. Lots going on here. This is really critical that you do understand this. So I hope you found this video helpful.